Hello guys, welcome to my channel. Today we'll be solving another Leetcode problem which is sort colors. In this problem, basically we have to sort the given array which is only having numbers 0, 1 and 2 and we have to sort that array. So the problem statement is given an array nums with n objects colored red, white and blue. Sort them in place so that objects of the same color are adjacent with the colors in the order red, white and blue. So this is just a twisted statement, but otherwise the problem statement is we are given an array of 0, 1s and 2s and we have to sort that array. And you must solve this problem without using the library's sort function. So when we read the problem statement, the quick idea that came to our mind is, okay, let's sort the array, arrays.sort, and the array will be sorted. But here in the problem statement, it is clearly mentioned that we are not allowed to sort it using library sort function. Okay. So what is the another approach or solution that come to our mind? Let's have a look. So here we are given an array with 0, 1s and 2s. What we can do is we can do a count of zeros, a count of 1 and count of 2. So what we can do is we can have count 1. We can have three variables. One will be keeping track of count of ones, count 0. It will be keeping track of count of zeros, and then we can have another variable count 2 which will be having count of 2s. So what we will do, we'll go through the array, we'll see 0 is there, we'll have count 1 here, 1 is there, we'll have count 1 here, again 1 will increment to 2, like that we'll keep on doing, and then in the end we will have 1 2 3 4 zeros with us and 1 2 3 4 ones with us and 3 2s with us. Okay, now when we have the count of each number 0, 1 and 2, what we can do is we will rearrange the array. Okay, we know there are 4 zeros, so we'll add 4 zeros in the array. In the same array we have to do it in place, so what we can do is we will replace this with 0, replace this with 0, and then this is already 0, we can have 0 here, then we can have 4 ones here like this, and then 3 2s. So this is one way in which we can sort the array, but the problem here in this is we are traversing the array 2 times, so the time complexity is order of n, 1 for counting and then again order of n for rearranging those numbers. Okay, so we are doing the array traversal 2 times, so it is like 2 pass algorithm which we are using here. So how can we reduce it to 1 pass? Let's have a look at that. Now to sort this array in 1 pass, we will use an algorithm called Dutch national flag algorithm. So the idea is we will have 3 pointers here, low, mid and high. So here low will be keeping track of zeros, mid will be keeping track of ones and high will be keeping track of twos. So since low is keeping track of zeros, so what we will do is we will point low here, okay, and high is keeping track of twos, and we have to push twos to this side and zeros onto this side, right? So what we will do is we will point high from the end, so this pointer will move in this direction and this pointer will move in this direction, and mid is for keeping track of ones, so mid we will start from here. We can start it from end as well, but I am starting it from here. So the idea is whatever will be on the left hand side of low, that will be our zeros. So as we will traverse through the array, what we'll try to do is we will try to have all the zeros in this direction, and similarly for high, what we'll try to do when we are moving in this direction, we'll try that all the twos come into this side. So wherever low is, all the elements on the left hand side of it will be zeros, and wherever our high is, all the elements to the right of it will be twos, and all the elements from low to mid, that will be our ones. Okay, so let's just traverse the array and have a look, and then you'll understand it better. Now our low is here, mid is here. Now we don't need to do anything because our this element is at its correct position. We want 0 at this position, 0 is there. So what we'll do is we'll move our low to here. we'll remove it from here. Now our low is at this position. Now we have shifted our low and mid to this position. Here the element is 1. So now we will not move our low, we'll only move our mid. So my mid is here. Why I have done here like this is, so low here is basically representing zeros, and what we are saying is all the elements to the left of low are zeros, but this element is 1. So we cannot move low to the next position until we will have a 0 here, or we can see it in another ways. Low is basically telling me the position where I have to put my next 0, right? And mid is basically telling me the position where my next 1 will be, and high is similarly telling me the position where my next 2 will be. Okay, so whenever a 2 will come, that 2 I have to move into this direction, right? I have to put it here. That's what this high is holding for me. Okay, so similar explanation I have also given in remove duplicates from sorted array. So that video I will add in the description below. You can go and have a look at that video also. Now I have moved my mid here and low is still at this position. Again, mid is 1. So I am also saying that everything between low and mid is ones. So here that condition also we are satisfying. Everything between low and mid is 1, right? Here all are ones. Now I will move my position of low to here. Now I have moved my mid to this position. Okay, so here it is 0. So 0 is here, but we want zeros in the starting. Now what we will do, we will swap this 1 with this 0. So low is holding the position of next 0 for us. So this 0 has to go in this position and this 1 has to come to this position. Okay, so this thing we have done. Now we will move our mid to next pointer here. This low also will move to next position. Now again the element is 0. Now again we will swap low and mid. Okay, we will have 0 here and have 1 here, and we'll move low to the next position and mid to the, we'll move low to next position, we'll do low plus plus, and mid also mid plus plus. Now here the next element is 2. So 2 we have to push to the end of the array. So what we will do is we will move this 1 to this position and this 2 we will take to here. So we will swap the elements at high and mid here. Have 1 now, and here we will have 2. Now we will reduce our high. High will do high minus minus. Why? Because high is holding the position where next 2 has to appear. So next 2 has to appear at this position, right? Here it is already 2. But here the point to note is we are not changing the position of our mid element. Why? Because when we are moving from this direction, we knew for sure that we have sorted all the zeros and ones that are coming in this direction with us. But when we are moving from here, we don't know what have come to us at this position, whether it is 0 or 1. So let's say instead of 2 here, if there would have been a 0, then here that element would have been 0, right? So this element 0, is this the right position for it? No, right? We have to move 0 ahead of ones, right? So that's why we are not moving the position of mid. So now here in the next pass it will see, okay, it is 1. So this is the correct position. All the elements between low and mid are 1. All the elements to the left are 0. And all the elements to the right are 2. Everything is looking good till now. Now we have moved our pointer to the next element. Now it is 2. Now 2 we have to shift to the end. So what we will do is swap it. So this will get swapped, but again my mid will be here, but high will come here. Now you see my high is pointing where my next 2 will come. Next 2 has to come here, and my mid is here. At this the element is 2 and here it is 0. So now we will swap. 0 will come here and 2 will come to this position. Now you can clearly see, right? If we have moved the mid here, then this 0 would have been at the wrong position, right? So that's why we are not moving the mid. Now we will change our high to this position. Now there is 0 at the mid. So if it is 0, what we will see where our low is, and we will swap it with the low. So here it is going to be 0, and here it is coming out to be 1, and low will move to next here, and mid also we will move to the next position. Now you can ask why in this case we are moving mid to the next position, but in high we are not moving. That is because low and mid are moving in the same direction, and also we know for sure whatever we have till now in that direction is sorted. So that's why we need not worry, okay, what is coming from this direction. We know because we are clearly making the statement that everything which is before low, that is going to be 0, everything between low and mid is going to be 1, but everything to the right of high is going to be 2. But we don't know what is between mid and high. That's why we have to keep mid at that position and move high to the high minus minus. I hope this is clear. Now everything is sorted. All the zeros are at the start, all the ones are in the middle, and twos in the end. So the breaking point of the loop is while mid is greater than or equals to high. Now let's have a look at the Java and the Python solution. But before that, if you like this video, please give this video a thumbs up, and also please subscribe to my channel for more videos like this. So here is the Java solution. I have initialized 3 variables, low, high and mid, high to the end and low from the start of the array, while mid is less than or equals to high. So this is my breaking point when I have to come out of this loop. Okay, if nums of mid is equals 1, if the element at that position is 1, we have to do nothing, we have to just simply increment. So that is mid plus plus. If the element is equals to 2, then we have to swap mid and high, right? And we have to decrement high, but we have to do nothing with mid, right? And again, if element is 0, we have to swap low and mid, and we have to increment both the pointers, right? And this is the normal swap function. I hope the solution is very clear after the explanation of the problem. Now let's have a look at the Python solution. So similarly for Python, I have written this swap function and have initialized 3 variables, low, mid and high. While mid is less than high, if nums of mid is 0, I am swapping mid and low and incrementing low and mid pointers. If mid is 1, I am incrementing only mid, and if nums is 2, I am swapping mid and high and decrementing the high point. If I have helped you in understanding the problem, please like this video and subscribe to my channel for more videos like this. Thank you.